Good afternoon, colleagues, or good evening.
Good evening, sir.
So I'll just wait around 5 minutes. I'll see who's going to join, and then subsequently, then we'll commence. All right, students. I've got a few on. Can we proceed? Hello?
I'm sure more people is gonna join now because they asked for the link to be
Okay.
reposted in the group.
Okay, cool. Thanks,
I just
thanks.
did that.
Okay, now wait, I'll wait. No problem. But while you're waiting on the others, I see um do you guys know the basic trig? No, I'm opening this up to everyone. Like, I don't know, what is your trig level competence? Because I wanted to actually just go straight into like what is this here, man? Those identities first, and then I wanted to go into equations next. Yeah. So can I hear from the colleagues? How good are you guys with trigs, or like where should I proceed from? You guys can talk, eh? Ashwin, Dalen, Kama, Lodi, Tanukazi.
So I just joined in now, so I don't know what are you asking?
Yeah, what I'm asking is that I'm not sure where I should start. Like, should I start with the basics, or like could I just get into like the identities and the equations? You know what I mean? Like, there's the actual main stuff. So that is what I'm trying to figure out.
Oh, just go in with the main actual stuff because I think we understand the basics.
Yeah, that's what I was also under the assumption with. I don't know how everyone else feels. Um, yeah, let me the people are joining, so it's fine. So, was that person admitted now, no? I don't want to spend time on basics if you all basically know. You know what I mean? Let me see. Identity starts somewhere. Okay, let me just give it around a minute, eh? Then I'm gonna begin. All right, colleagues, can we begin? So there is time here. Let me see where I can begin from. Okay, cool. So let me just start, and then if you're unsure of a particular, what is this, concept, you can just let me know. Is that fine? Is it fine, everyone?
Yes, sir,
Uh,
it's fine.
Okay, can someone else besides Tanakazi say something? If Tanakazi is talking there.
All good, sir.
Okay.
Oh,
So, yeah, so
Yes,
we're gonna
sir.
begin, and then you say, okay, sir, I'm not familiar with that concept. I'll go back and I'll do it. But I want to just get into the main solving stuff. You know what I mean? Especially the identities and equations. But I'm gonna start off with the compounds, and then we're gonna proceed nicely. So again, please, if you're unsure, don't treat this as a lecture where I'm leading. I'll lead the session, but then if you're unsure of a particular thing, I will explain exactly, you know what I mean, where it comes from, and so forth and so forth. And I'll show you in the textbook as well. So anyway, I'm assuming you all can see the OneNote, and let's start off with this problem over here. Okay. So over here, they say sine A equals something, cos B equals something. They're both angles, AB being acute. I'm assuming everyone knows what acute and obtuse angle is. It says calculate the following. Number one, sine A plus B. Two, cos A minus B. Tan 2A, sine 2B, cos 2A, and then cos 2B plus 2B. What you're seeing right here is something called the compound formula at play. And the compound formula, I'm not sure if you guys are familiar with them. They look like this. So let me quickly show you. Are you guys familiar with this over here? Can you guys see it? Just get a yes or a no, as I can't see the thumbs.
Yes, sir.
Okay,
Yes,
great.
sir.
Okay, perfect. Right, so let's quickly go through this one as a warm-up. Now we'll progressively try to make it more fun. Okay, obviously don't watch me do it. Solve with me as we go along. Okay, so how do we do this? Let me just quickly go. Yeah. So we've got two angles, and then we need to just, let me first see. So if I want sine A plus B, right, we obviously have to now, let me just make this smaller. Okay, there we go. Sine A plus B. What's fortunate here is that they've given us obviously the angles. Obviously, we can find the value of sine A plus B if required, but we don't need the actual angle yet. So what we first do, we expand our sine A plus B using the compound formulas. It'll be interesting to show you maybe later on where this comes from. It's possibly useful. And here we have these. Okay, so sine A plus B, you expand up according to this compound rule over here. Okay, all we then do, we know the value of sine A, it's 5 over 13. Cos B is 15 over 17. We add that to cos A. Now this is where we need to adjust. So typically, before you actually want to tackle these problems, this is what you're supposed to be doing. So I'm going to draw a sketch for you quickly here. And this is going to be of angle A. So can you guys remind me what is sine again? You don't mind? The trig ratio of sine, what is it?
Opposite of hypotenuse.
Thank you. Okay. I'm assuming people know. So therefore, the opposite angles over here, right? We always know the hypotenuse is exactly opposite the 19. So that's 5, 13, 5. And if you're familiar with this should, I believe, be a 12, right? You can obviously find it with Pythagoras. So if you're unsure of that, you can just let me know. They're acute, so it's less than 90. And this will be angle A. So I'll do another sketch for you, which is going to represent B. Let me just choose blue rather. We can do that over here. Okay, we're just warming up here. And then it's this chords would be adjacent, and then hypotenuse if I'm right, and that's in the angle P. And obviously, if you do a 17, 15 triangle, I believe, am I right, is going to be, okay, it's 8, right? So this would be 8 over here. So once you have these two triangles, you can easily pull information from this. So if you want cos A coming to this, cos is going to be adjacent over hypotenuse, which will be 12 over 13. You guys agree with me? Let's say
Yes,
yes.
sir.
Perfect. Okay. And then we obviously have to do this case I want cos B. And we have cos B already, right? So cos B is given as 15 over 17. So when you generate these triangles, it's going to be useful when they're going to want other trig ratios besides the ones that they give you. So I'm just making you aware of that. So then after this, we
Sorry,
obviously,
sir.
yes.
Sorry, sir, isn't that could be
Shouldn't that
sine
be
B?
sine of
Realize.
B?
Yeah, I mean, you see, there we go. My mistake, guys. Thank you. So it's sine B. Yeah. Okay. Sine B, I was wondering now, yeah. Sine B is going to be, it's 8 over 17. Are we happy with that? Here we go. Do we get that? I believe we're all content with that, eh? Dylan, Tanakazi, Heinrich. What's going on here? You guys good?
We good, sir.
Okay,
Yes,
say
sir.
yes, man. I can't
Good,
see your
sir.
thumbs. I
Good.
can't see your thumbs. So yeah, bear with me. And now let's return. So obviously here, it's just a case of, they're not stating whether you can use a calculator or not. But obviously you want to just multiply everything through here. Okay. I'll quickly do that. Sometimes they say, you use a calculator or don't use a calculator. I think using a calculator is fine over here. So if we do the 5 times 15 times 13 times 12, you should get 75 over 221. Correct. And then we have to obviously do the other side, and that's going to be 12 times 8, which is what again? 96, eh? Yeah. And then 13 times 17 will give you the 221. Okay. We then must just simply add these two fractions up, and we should get our answer of 171 by 121. Pretty straightforward, eh? Are we winning with this, guys? Can we all do this kind of stuff?
Yes, I'm okay.
Okay, perfect. So I'm going to tick him off. I'm assuming we can also do A minus B. Is that fine?
Yeah, that's
Okay, I'll tick him off as well. Fine. Cos tan 2A, is anyone familiar with that one?
yes.
Yes or no?
Yes, I'm familiar with it.
Okay, so what I'll do now, before I'll thank you for that encouragement there, is I'll put up the double angle identities, right? Because I want you guys to possibly do for me sine 2B, one of these two. So just like with the compound formula, I'll explain to you where this one comes from at least. Yeah, so as you can see, it's a cos 2A, which obviously we have 3 options for the cos 2A. There you go. We have sine 2B, which is obviously a case of this on top, and then we also have the tan 2A. So I'd like you guys to do for me the tan 2A and maybe the cos 2A, right? But before that, before I give you the ones to do, I just want to quickly show you where these double angle identities come from. So let me just do a new section here so we can have it open. And that's hard to solve problems. Sometimes you're unaware if people know. So again, this sine 2x is essentially equal to sine x plus x. Is it not so?
Yes.
Perfect. And if you recall your compound formula over here, if we apply the compound formula here, so that's going to be, oh, sorry, let me come over here, sine x, right? And that'll be cos b, okay? Which is cos x, right?
Yes.
Plus, what is it? Cos of a, which is also x. Am I right?
Yes. Cosine x. Yes.
And the other one is what? Sine x, right?
Sine x. Yes.
Yeah. What do we do next? We add them up, right?
Yes.
We have two of them. 2 sine x, cos x. And that's where this guy, I don't know why that also copied over. That's where this guy comes from. You see that? Number one. You guys with me? If I do cos 2x,
Yes.
just as a just as an illustration, that's going to be, of course, cos x plus x. In this case, we got our compound formula for our, what is this? For our cos. In this case, it's going to be cos x times cos b, which is cos x, right?
Minus
Minus sine x times what? Sine x.
sine x.
And obviously, we get the old faithful cos squared. You know what I mean? If you know it quite well. The cos 2x over here. And then, just to take it further, just to open your minds a bit, let me just delete this part now. If you, what happened here? Just delete that. Okay, perfect. So we got this one and we got that one. And obviously, how do you want to get this to? So I typically just remember the one, which is the cos squared, the cos 2x, cos squared x minus sine squared x. So this one, I use the Pythagorean identity, right? Of sine squared x plus cos squared x equals 1, right? You guys familiar with that one?
Yes.
I'll explain to you that comes from in a later stage. And all we do here, we put one in terms of the other one. So let's say I'm going to do sine squared x. And that's going to be 1 minus cos squared x. And I take this bad boy, I substitute him in here. So there will be cos 2x squared minus 1 minus cos squared x, right? I simply then just multiply through the negative, which is negative 1, plus a cos squared x. Add that one and that one. That's 2 cos squared x minus 1. Can you guys see that cos 2x equals 2 cos squared x minus 1? It's over there, number 3.
Yes.
Are we happy with that, colleagues? Did you guys know that?
Yeah, that is quite clear from my side.
Okay, okay. Thank you, Richard. Dalmarie, Kama, Lori, London. Are you guys familiar with that?
Yes, sir.
Yes, sir.
Okay. Okay. Tell me if you know it, I don't have to do it. Hey, I'm just going over the necessary fundamentals here.
Yes.
Okay, so what I want you guys to do now is, like I said to you, let me just remove that one. I'll come over here, paste him over here. Do for me number 3, and I want number 5. So let me just erase this. So your objective is this guy over here and that guy over there. Then I'll check the answers. If I need to do it over, then I will do it for you. So let me give you, let's say, 3-4 minutes. Okay. Begin.
Yeah. What happened here now?
And if you're unsure, you can easily just raise your hand and then I will obviously assist. Yeah. Just let me know. I'm gonna try to do a lot of the advanced stuff. Yeah, it's what I want to get into. Let me see. Yeah.
What the hell?
I'll just say stop and then we will, yeah.
I've got a little bit of problem. I can hear you, but everything is different now. You have to log in again.
Sorry, Richard?
I say I've got a little bit of a problem here with
Hmm.
I can hear you, but the interface is now
On.
I can't see anything on it.
Just maybe log in and log out again. Yeah.
Okay, I'll try that.
But it's all in the textbook though.
Yes, yes.
So yeah.
Oh yeah, there we go now. There we go.
Okay, yeah. Great.
You say we must do tangent to A.
Yeah, that's correct. Tangent 2a and cosine 2a. And just by the way, for number 3, you could have also done your sine 2a divided by cos 2a. It'll also still give you tan 2a. Just by the way. Actually,
Yes.
it comes from there.
That's another identity.
Yeah.
So,
So we have sine 2a already, and then it'll be easy just to work it. Yeah, just letting you know. Okay, so let me say 2 more minutes and then I'll put up the answers and then, yeah, so we can move, honest to move. The stuff that you possibly do not know. Okay, go here. It's identities. Okay. Okay. The identities, I see I'm gonna have to. Yeah, I must see what I know I must do there. Okay. Okay, 1 minute, guys. 1 minute left. All right. Are you guys done? I hope you guys are done.
it's just a couple of minutes here, some.
Okay. Good. Give one more and then yeah, because I want to move. And I want to come to a point where people are like, sir, I don't know what's going on. That's what I'm aiming to get to. I just thought I'd go over start to cover some fundamentals as a move. Okay, let me just quickly see here. Identities are working. Okay, perfect. Okay. All right. Can I quickly come in and just give you the answers and see if you've got it? Let's quickly see. So for 10 to A, you should have gotten 120. 120 the value should be equal to 120 divided by 119. And then the cos to A should be equal to, cos to A is equal to, let me see here, 119 divided by 169. You guys get that? Talk to me.
Yeah, close to, but not
Yes, sir.
100%.
Okay, this close.
Yes,
Yes,
sir.
that's good. London, Thailand, Chipolile, Subuyo.
Got it.
Okay, great. Okay. Should I move on? Are we happy with this concept? Not too bad. Can I proceed?
Yes, sir, mate.
Yes, my side, yes.
Okay, great. Okay. So let me come to I want to solve two identities now. Okay. Proving identities. I'm sure you guys have seen that. And let's quickly try that out. And I'm talking about the following now. I'm going to show you now. Let me just share the book first, then I'm going to go to that. So obviously there's a lot more which I want to talk about here. There is another proof I want to show you, but that's with the other ones. But I think I might get to a place where you guys are going to have to look at it. But it seems like people are fairly okay with trigs. So what I'm talking about is unit 3.4, if you guys can see it, and it talks about applying and proving trigonometry identities. Okay, this is what I'm talking about. So it's these things.
Yes.
Yeah, okay. So this is what I want to go through. And then obviously I will try to bring some basics through this as I obviously solve them. So I'm gonna try to do example 3.19 on number 1 and number 2, and then you guys can obviously attempt something else. Or maybe
If I can ask, if you perhaps can assist us with activity 3.220.
okay.
Number 3. That's the one I struggle the whole day with.
This one over here.
I try to at least give it a fair chance because I know about the team's meeting, but that one seems to give me some headaches here.
If the rest of the class is happy with to proceed, then I can easily just do it. It's up to them. Yeah.
Then on the applying and proving identities,
Yes.
I follow this rules. It's quite clear what to do. Is there any other like way to look at the problem before, except for this? because we all know that write it in simple terms like a cosine and sine.
Yeah.
And then first remove the highest common factor, and then
Yes.
all those kind of things. But sometimes it feels like, especially when for me now, when it comes to activity 3.20,
Yeah.
the third one, it's almost like there's, for me, look like there's nothing to factor.
Yeah. So the honest truth is that there is no set steps. You need a lot of mathematical flair, man. You know what I'm trying to say? You gotta be a bit sexy. Sometimes it's not just steps. You know what I'm trying to say? You need to say, okay, you need, like, remember that one you asked me on the group, and I don't want to spend too much time with the x minus 9, and you need to know that
Yes,
you can also
yes.
you can also make it root x minus 3 plus. It's that type of stuff you need to be able to also, you know what I'm saying to you?
Yeah.
Yeah. But okay, let me I don't know, the rest of the class is not saying anything, so I wanna, you know, I'm trying to for all of us to move through here. Let me just quickly see here. Let's try. Okay, class, where are we at here? You know, like I said, I want to lead, but at the same time, I don't want to do things that you guys know already.
Yeah, like I say, for my side, this proving identities is sometimes headache, but not all of them. I try to
Yes,
do
yes.
most of the stuff, but at some ones, then I almost like I hit the wall. But so if we can give some, but like you say, I understand what you say. It's not like specific steps. You have to look at the thing holistically and solve it from there.
Yeah. I don't know. Okay, people's not saying much.
Yeah, that one, 3.20, number 3.
Okay, yeah,
That
I
one is
see.
giving me that. The first two was fine. I managed it first attempt. That number 3,
Okay,
I think I need some help on that one.
okay. Can we just do number 3, colleagues? I don't know where everyone is, man. You know what I'm saying to you? I like this type of you know.
No problem,
can,
sir. We can carry on.
okay, cool. So let me do something quickly. Let me do 3.21 just as a warm up, you know, and then I'm gonna do the next one. Is it fine? Just to show you. Yeah. Just to, you know what I mean? Yeah. So, I mean, okay. And guys, I like this. I like this. This is what I'm looking for. And whatever you want, you'll get. You will see. But I need that engagement. Okay. So this one, I think you will enjoy what I'm gonna do with the other one. Let me just quickly share out the book. Then I'm gonna. So I wanna be useful in solving these problems. Right though. Okay. So with this one, let's try to see what we can do here. Just as a warm up. So the key thing in the way I view this, right, is that you need to be able to know your identities. That is the key. So what I'm talking about is, like, you need to know that sine over cos, right, is equal to 10. You need to know cos squared x plus sine squared x is equal to 1. Obviously, there's other identities following this. You guys know the other ones as well?
Yes.
The ones with sec and tan, right?
Yes.
So you need to know those ones, the one with sec and cosec as well. That's what's key. But there's some other techniques which I'm going to show you right now. But anyway, let's quickly try to solve this one. And there's many ways to solve these problems, by the way. It's just not one way. I want to be clear. So let me try to do the first one on top. So the first one, when I look at this, I'm like, okay, there's a cos 4x here. And that is not something we want. We want to work with the stuff that we know. So we reduce it. I'll take cos squared out because I know that is something I'm familiar with, right? So that's cos squared x. Then I'm left with plus sine squared x. Now I'm feeling happy on the numerator side already because I can already see there's a cos squared x plus a sine squared x. You know, that's going to give me a 1. That's giving me some peace already. Perfect.
Yes. Yeah.
But now, yeah. So now I go 1 minus 2 sine x plus sine squared x. This looks suspect. Especially if you're not sure. This is what I'm talking about, the flare. So another way, what you must also be able to discern is whether if you have something like 1 minus sine squared x, by the way, you know the difference between two squares?
Yes.
1 minus sine x. Can you see what I'm saying to you? That you must be able to see, man. You know what I'm trying to say to you? So here, if you familiar with this thing at the bottom, 1 minus, I'll just make it 2x minus x plus a x squared. This is a trinomial, right?
Yes.
And if it's a trinomial, I can factorize. Are you guys with me? So Richard's the
Yes.
only one who's talking to me. So that's the thing you must also look at. Cos squared x. And I'm gonna have okay, can I make him sum one time instead of me wasting my time? Is that fine?
Yes.
So now the reason why I'm factorizing this because I can't apply the root to each term over here because they're separated by a negative and a positive, right?
Yeah.
So I need to find a way that I can apply that root so it can be eliminated. So what I do now, I keep my root must be there, then I factorize this guy in the middle. So there'll be 2 brackets. Okay. So if you know, this will be sine x over here. It's like my x, right? Obviously we need to have 1s at the end, am I right?
Yes.
But it must be 1. There must be a negative here and a negative here. So the way I know my factorization, sorry for my small signs there, let me just make it a bit bigger. This is the way I check my factorization. I know that sine x times sine x must give me a positive sine x, a negative sine x plus negative sine x give me a positive. Is that fine?
Yes, that's fine.
So what I do with this, I know that the 1 times the 1 must give me a positive 1. Is that correct? Yes,
Yes,
1,
yes.
yeah.
That's always
And what I
nice.
do here, this in totality, if you actually look at it properly, it's actually negative sine x, and I can add a negative sine x, which will be negative
Yes.
2 sine x. I don't know if you have that experience, just by the way.
Yes.
So that is my next step there. Okay, but now we have, if you look at it, we have 1 minus sine x, 1 minus sine x. That's 2 of the same. Therefore, if I were to have 1 minus x times 1 minus x, this is also 1 minus x squared. Am I right? Yeah.
Yes.
That's also an element of flair you need to be able to identify. It's a lot of that flair you need to see. So it's 1 minus sine. 1 minus sine, what is it? X squared. We then also know that a root in a square, you know what I mean?
Yeah, they
To the
can.
power of, we say it cancels if you like. Then we're going to have cos squared x divided by 1 minus sine squared x. This is actually a tough one. And back to what I said to you. Now we seem like we're stuck. So we have some alternatives we can actually use here to reduce this one. Okay, there's not squared at the bottom. Sorry, there's just x here. Sorry, my bad. So there's no alternatives. Okay. So remember the square is cancelled here.
Yes.
So now over here, it seems like we're kind of stuck. But if you know your Pythagorean identity of cos squared x, you're also familiar that it's also 1 minus sine squared x, right?
Yes.
Exactly. And so another aim of what you're trying to do here is you're trying to get the ratios to, for instance, there might be sine, cos, and tan. You're trying to normally try to work towards one ratio, depending, on the
Yes.
question. Yeah. That's another thing you have to think about. So on top, we have this, and we have the 1 minus sine x. And then obviously, this again is another difference between two squares, 1 minus sine x. And we have 1 plus sine x. Colleagues, are you all with me here? Besides
Yes.
Richard?
Perfect.
Yeah. Okay. And obviously, that guy and that guy
Yes.
divides out, and we left with this slave queen at the bottom. 1 minus sine x. All right.
Yes.
Can we see all that? What you had to know was a lot. This is a tough question. I'm not gonna lie. This is not one where you actually, straightforward. Is there any questions with this one that I should go over maybe again? For the ones who are unsure. I'll give it a minute, and then you can just ask me. And at any point, just check this one quickly. Proof. Any questions, colleagues? Don't be shy. No questions.
I have
So,
no question message.
okay, Ashwin, Gama, let me see who else is here.
No questions, sir.
Kapongwe, Polile, Heinrich, Diteta.
All
No
good, sir.
questions on my
Okay,
side.
great. Okay, so now, and thanks for
Oh,
Richard for that.
sorry,
Yes,
sir.
yes. Who's that?
I am calling. The only
Yeah.
part said that was confusing. That it is the denominator, as they have not put it in a. It is in a complex form, unlike a quadratic as and quadratic, it is not in that manner of a quadratic equation. It is the one that was confusing, but you have explained it, I've understood it.
Okay, thank you for that. And that's what's important. Like you need to be able to, what I do sometimes, I even put things in terms of X and Y. You know what I'm trying to say to you, to make it easy for myself. Are you with me?
Yeah.
So let's
Yeah.
say, so let's say we call Y equals cos, and you're allowed to do this. X is equal to sine. You just bear with, mathematically, obviously. And then we can say Y to the, okay, in this case, it's a bit tricky this way, but I'm just saying sometimes you can just replace them with simple variables, in order to solve. Now let's quickly do the one Richard requested. I'll try to find one more after this, and then we can proceed again to the next one. But please just keep on asking. Okay. So this one, what do we do here, colleagues?
Okay. In top, we see there's an identity. There's a 1 plus identity, and that identity is 2 sine x. That's what I changed that to 2 sine x.
Yeah.
I mean,
Sine 2x.
Sine 2x, yes. And then at the bottom, there's nothing to factor. But the one you can also write is that granddaddy 1.
Yes.
So I tried that way as well, and then I got stuck at some point as well. So 1 is then 1 sine squared theta x plus cosine squared x, and then there's a plus sine 2x.
Okay. Anyone else want to say something before we say something? I'm hear someone talking there. What's going on, man? We can hear you. Can I be muted? Don't worry. Okay, so let's quickly see. So there's many ways I think this one can be solved. I guess just the way you're gonna wanna look at it. There's many things I see here. I wonder if it's gonna pan out the way I think. So let's quickly try. Let's see. So over here, I'm thinking now. Okay. So obviously you see the first move would be like this, right?
Yes.
Sine x, yeah, plus cos squared x. I mean cos, okay? So this is not, I feel a bit stuck with this one, right? What do you guys think?
I've got stuck with it big time.
Yeah, so that looks a bit okay. Like, where do I move from here, right? I don't think it's a good place to go. It could be the deceptive to just do the 2 sine. Maybe another way would be this. Let's see. If I check this out, so you see the 1, right?
Yes.
1 is also equal to cos squared x plus sine squared x. Check
Yes.
that, right?
Yes, I tried that
What?
as well.
Right? Plus 2 sine x cos x.
Yes.
Okay? I divide in. Sine x plus cos x. Okay, this is where you must be a bit blessed, I think, now. Watch this. So what I'm going to do now, I'm going to rearrange this differently for you. Check this out. Sine x squared, no? You see that?
Yes.
Plus 2 sine x cos x. Plus. Check that out. You see?
Damn it.
Yeah. So it is hard to teach. You can't teach someone this stuff, man. You know what I mean? It's just
that is where the savvy thing comes in, I suppose.
Yeah. You got to be a bit sexy here. So then obviously this is going to be sine x, no? And obviously this one must be cos x, no? The plus, what's it? Plus cos x, right?
Yeah.
And the other one must be what? Also sine x plus cos x, isn't it? It must be the same. Am I right?
Yes.
It has to be the same, right? I think I'm right here. I hope so. Anyway.
No, that is perfectly
Yeah.
right. One
And then
cancels
plus cos
the-
x. And
one
obviously
cancels out
one's gonna divide the other one, and you're left with
sine.
sine x plus cos x. Yeah.
Damn it.
Yeah. Okay. That's for 4 marks, let's say. Okay, let's can I give you guys another one?
Yes,
Was it-
please.
Okay. Are you guys
Yes, sir.
is Richard my only student here? What's going on? Talk to me,
Yes,
man.
was more-
Yeah, let me try.
Sir, can I just ask you,
Yes.
how did you, apart now from the savvy and you have a feel
Yeah.
for it, how did you identify that is a middle term of a trinomial?
Okay.
What
Quite.
is it? Yeah.
No
How did
problem.
you? Because I look at the thing, my eyes got squared because I couldn't see anything else.
No, I'm with you, man. The thing is, I see the 1 plus sine 2, right? So I'm like, okay, that's in my brain. This is the first thing this is the amateur move, right? Because
Okay.
you rush to this, okay? But now when I look at this, I'm like, I can't actually further reduce this.
Yeah, this is now
So
stuck in there.
because my other thinking was the only other way is to now I must apply squares on everything, right? I can square the top and I can square the bottom. You know what I'm trying to say to you? But if I'm going to do that, I'm going to end up with a sine squared 2x, which is the last thing that I want. Does it make sense what I'm saying to you? Because that's going to be a whole other mess now. Then I say, no. It cannot be that. This is what's going through my mind as I was doing it, even before. So then I'm like, okay, I can't do that. Park him. But then I'm like, no, man. That 2 sine x cos x, right? It can't just, it's not useful. The other alternative was what I was thinking was, okay, if I say 1 over sine x plus cos x, right?
Mhm.
I'm basically separating each one. And let's say I make this 2 sine, what's it, sine 2x again?
Yes, yeah.
And I divide this by sine x plus cos x. If I make this again to 2 sine x cos x, I'm like, nah, man, this is gonna put me into another yeah. But then there is another way to do it. So what I could have done also was do a no. Then I was basically stuck. So I was like, okay, that's fine. It's not gonna work out. I was doing this in my brain. Then I tell myself, no, man. I always know with this experience or the one is always cos squared plus sine squared. And I know it's always useful somewhere along the line. But when I came here, I'm like, oh, okay. If this is the denominator, I know that this cos squared plus sine squared plus 2 sine x cos x, that's some kind of trinomial. So I think it's just experience. It's not any specialty or whatever. So
my second attempt was like the way you did it, sir. But
Yeah.
I couldn't realize that a 2 sine x cosine x is actually a middle term of the cosine squared x.
I hear you.
sine squared. And so I stuck basically after your the second line, I got stuck there because I couldn't notice that 2 sine x cosine x is actually a middle term of the identity.
Yes. Okay, guys, so that's fine. Try this one. Ignore the top section there. Yeah. Okay, try this one. Now, this one, college, just before you start, always if you see two terms like this, typically what I want you to do here is do the common denominator thing. I'll illustrate this one. Let's say I have 5 over 8 plus 10 over 17, right? You know common denominator, you say 8 times 17. You guys know this thing?
Yes.
Right? And then you say 17 times 5. Keep the sign 8 times 10. You guys know this thing?
Yes.
Okay, so when you see two fractions like that, that's typically what they want you to do. Take a common denominator and cross multiply. I'm just letting you know. Okay, try that one out here.
That's cool.
Yeah. Just letting you know. You'll see what I mean. I'll give this one 5 minutes, right? Maybe I can check for another one of the past papers as well while we're here. Okay. 4 more minutes, colleague. Three more minutes. All right, 1 more minute. Did anyone get it?
Not yet, sir, on my side.
Okay, okay. Are you battling or you?
I'm still working it out.
Okay, okay. All right, colleagues, do you need more time or should I come in?
Give me 30 seconds.
Okay, okay. All right. Litsakanya, London, Dylan. Tanokazi, can I go? Marie.
Can I get 2 more minutes, sir?
2 more minutes. Come on, man. Okay, I'll give it 2 minutes and then I will, yeah. Then we can, then I'll see.
Thank you, sir.
Sure. All right, I think that's enough time, eh? Who got? Did anyone manage to get it? Did anyone manage to get it?
The two, I've got the two is bothering me now. I've got the cosecant, but not that two is somewhere now missing now.
Okay. Can I begin?
Yes, sir.
Okay, cool. Let's do this. So, first thing out of done, I'll do the common denominator thing. So it's I'll take the denominators and multiply them together like this. Is that fine with everyone?
Yes.
Yeah. I take sine A and sine A, so it's sine squared A. Then I take this guy and that guy there, right? So I have 1 plus cos, what's it? Something like that. Is it fine with everyone? Okay. Then I have to work on that side.
Yes, sir.
We all get to this part.
Sorry, sir.
Now, yes,
Is it okay if you write it as cos squared A?
cos squared A. No,
Yeah.
it must be like this.
Oh,
Because you remember you're timesing this thing by that thing. It's not just cos A times cos A. You know what I'm trying to say to you?
yes.
You're not just saying that times that. That's the whole thing. You know what I'm saying to you? You must view that as one,
Yeah.
as one number, if that makes sense.
Yes,
Okay.
sir.
Okay.
Just a question on my side. Is it better to FOIL it out that one
Yes.
cosine A or in one
I'm
cosine?
gonna foil him out now. Yes.
Oh, okay.
Okay. The reason why I'm gonna foil him out, colleagues, is because I know that the granddaddy, like you said, is gonna be one somewhere. You know what I mean? So I'm hoping for this to come out nicely. Are you with me?
Okay.
So that is another thing that I'm hoping to see. Anyway, let's quickly see. So I say sine squared A plus this one this will be 1 plus 2 as a 2 cos A, right? Plus cos
Yes.
squared. Is it correct?
Yes.
Yeah, right. So I just come here. Would it be beneficial to times this in? I think I'll leave the denominator as is for now. No?
Okay.
Yeah, I'll leave the denominator as is for now. I don't think we can work him as of yet. And bear in mind what I'm looking for. I know on the top somewhere, right? You see there. Just check. I want to give you my mind. So the answer is 2 cosec A, right? Guys, happy with that?
Yes.
So I know what this supposed to be is 2 sine A. Are you guys with me?
Yes.
So what I'm trying to say is I know on the top I must get a 2. I know at the bottom that sine A must stay there. Are you guys with me?
Oh,
You see what I'm saying to you?
I see now.
So
Yeah.
now I must sort out that 1 plus, what is it? that 1 plus cos A, that must go somewhere, right?
Yeah.
Yeah, that's what I'm thinking now. Okay, I'm just making you aware what I'm trying to see. Now, I know that my sine squared plus, what is this here?
Cosine is 1, yes.
That's 1, right? You think you guys are gonna love me for this?
Yeah,
Watch this
that's
magic. Watch this magic. So you have sine A over here. Now, this is also what? This is 2, right?
yes.
Now check, come on, man. Watch it happening in front of you. Cos A, sine A. Then I take it the common factor on top of 2. How are you guys? Hope you guys are you with me on top? You see this?
Oh, perfectly.
Yeah. Oh, this is in a bracket. This is in a bracket, sorry. Before I get too excited. Then I know at the bottom I have was 1 plus cos A, right? Times the
Sine.
sine A. And of course, you must know what's going to happen now. Cancel on cancel. I'm left with the what? 2 over sine A. Therefore, that's going to be 2 over 1 times 1 over sine. Just in case for the guys who are not aware, that's going to be cosec, right?
Yes.
Yeah. Is everyone happy with that? We
Yes.
can discuss. Yeah.
Sorry, sir.
Yes,
So-
yes.
Can you go back to the
Of course.
yes? Can you go up a little?
This is up. This is
Can I
max. Yes, Chief.
So I think was the one in this on the third step.
Yes.
Most the one on the third step is coming from the sine 2a plus cos 2a, cos squared a, I mean.
Yes. So this, I'll come here. I'll expand for you now. So you know that 1 cos A squared is the same as 1 plus cos A. Am I right? And 1 plus cos A. You happy with that?
Yes, sir.
So 1 times 1 will be 1. 1 times cos will be cos, right? Cos times 1 will be cos. Cos times that will be cos squared, right?
Yes, sir.
1 plus cos A will give us 2
Two
cos A.
cos.
Yeah, I hope you, yeah.
I was talking about the third step.
The third one.
Yes.
Yeah. So the third one, so the third one, we are just simply taking, let me just get my colors here. I'm just taking, because this one was always prevailing. This one, you see that one?
Yes.
And that one is 1.
Yeah.
Yeah.
Okay. Thank you.
Yeah. It doesn't have to be next to each other. Obviously, you can rearrange it in that way. Yeah.
Okay, sir. Thank you.
Okay. So any other questions?
Just quickly, so the key thing to start with is when you see a question in that form is to find a common denominator.
Yeah. But like I'm saying, it's not, my mind is not working in steps, man. You know what I'm trying to say to you?
Okay.
It's working in like, that is my solution, right? Okay. I'm working both sides concurrently. I know it sounds a bit weird, man, because you know what I'm trying to say? I'm checking, okay. Because when I came here, I was like, no, man. On this step, the first step, I'm like, what? If I'm going to expand this, is it going to be necessary? Then I'm like, okay, it might be because I look on this side here. With that sign, I can't go away for me to get cosec. And I know I must get it 2 somehow.
Yeah.
So that's what's kind of happening. It's a bit of experience happening also here. But okay, let me just quickly get another one. Should we do one more of this?
Yes, please.
Yeah, okay. I'm getting from a past paper quickly. 2024. I just sent it to myself now via email. It's April 2024, by the way. So yeah. And let's see if you guys are able to. It's for 5 marks. Let me just zoom in. And I'll do the next one as well, and then yeah, we can conclude. And tomorrow we can do equations after that. Where's my zoom here? Okay, here it is. Let's put on screen. Sorry about that. Just Okay, here we go. So guys, try to be quick. I mean, I can't really rush. So this is April 2024. Question 3. Let's call this guy past paper. All right. You see your first one? Can you please try 3.1? Is that fine, colleagues?
Okay.
Yeah.
Yes, sir.
And then I'll do 3.2 afterwards. I want to touch on one of those ones. Yeah. So I think with this one, if I look at it, that sine squared, that sine cube obviously must become a sine squared somehow. But I think I'll probably expand that sine to x and take out a common factor somewhere. That is what my thinking initially will direct me to. Because I mean there's no identity for sine cubed, technically.
Yes.
Yeah. Yeah. So you wanna make the sine to x. Yeah, no, for sure. That'll be the good step, yeah. Like just like you just said, factor. You probably have to factor a common factor somewhere. And obviously, colleagues, I see tan x on the right hand side, right? So obviously I'm thinking on top there must be a sine and the bottom must be a cos.
Cos.
You see what I'm saying to you? That's how I'm thinking. So that cos x is probably going to stay just there. The two must somehow cancel out. Okay. Where are you now? Okay. Colleagues, are you guys winning? You've got it, just say done. All right, people, what's happening? Are we winning, colleagues?
Almost there, almost there.
Okay. Good. Okay, 1 more minute. Okay, colleagues, can I come in?
Okay.
Okay. Let me just check the house. Ashwin, Delmarie, Kamal, Itetas, Singer Sharp, Skanya, Heinrich, of course, Richard, Sipolile, Lori, Anukazi. Guys,
Good, sir.
there? Okay.
Yes, sir.
Can I move?
Yes, sir.
Yes,
Move,
sir.
Perfect. Let's skip this color. So sign. So guys, when you do maths, the first thing you do, you probably want to pray, right? And the second thing is also remember all the promises you made to your family. Buy the new car, all that stuff when you're studying. It's very important to stay motivated when you solve these things.
Okay.
All right. So my first step was, like I said to you, I'll expand the sign to x, right? To sine x like this. And I'm really liking what I'm seeing because I'm already seeing a cos squared. You see what I'm saying to you? I like seeing that. I'm already happy. Then what I do, I'm divided this by 2 cos. And again, colleagues, in my mind, I know that tan is equal to sine x divided by cos x. So I know that this cos is not going to go away, and that 2 must divide out somewhere on top. And luckily, we have a lot of 2's on top, if you guys can see that. What I then do, I think I can take out, I can take out 2 sine x. That's the common factor, no? You guys agree with me?
Yes.
Yeah. And there I have a sine squared. I'm already happy with that. And of course, I have a cos x times a cos x, which is already amazing. Wasn't as bad as I thought it was. You guys see that?
Yes.
Yeah. So that's that. And then, that's just 2 cos. And as Richard said, that's the granddaddy over there. It's cos times cos, right? So we can just sort him out quickly. And that's cos squared. Am I right?
Yes.
Yes, sir.
And obviously, this will be 2 sine x. This will just be a 1.
Yes.
Why not? Exactly. And we have a 2 over cos. 2 divided by 2, sine divided by cos, tan x. 5 marks for you. Not too tough. Guys, get that?
I
Yes, sir.
somehow ended up with a -10, so I made a mistake somewhere.
Okay, I wonder maybe it's your identity. Maybe you made the sine squared x minus cos x. Just check because that's not the same thing. No?
I do have sine squared x minus cos squared
Of
x, so
course,
I
of
made a
course.
mistake somewhere.
Yeah, no, that's the mistake because you went somewhere there. Okay, so let's.
Just quickly on that second line,
Hmm,
there is sine. You got sine cube x, and then 2 sine x.
yes.
I can't make up what you wrote there
Oh,
after
the
the
second.
2 sine x.
Yeah, on top.
Yeah, right there is
So this here is the sine to x. This here, you get that part. That's an identity.
sine. Yes.
Yes. So that's it basically. And what I'm saying is now, what is common? What is common between this term and this term? I see a sine to x. You see what I'm
Sine.
saying to you?
Yes.
So if I say sine to x times this, I get sine, you know what I mean? Sine cubed x, right?
Yes.
That times that. That times that will give me that over here.
Okay, perfect.
You sure you see it, no? You're
Yeah,
100% sure.
I see it now. Yes.
Yeah, okay. As long as you do, that's what I'm happy. Right. That's done. So let's end off with 3.2. Let me just screenshot him. Are you guys familiar with the reduction stuff? Are we all familiar with reduction? How to sort this out? Yes or no?
Not so much, but you can give us some
Okay.
hints there.
Not fully, sir.
Okay. So we'll work this two together, right? So what is key here? You're obviously going to see, oh, there's 180 plus one. You know what I mean? You know what I'm talking about? 180 plus, and you know,
Oh,
yeah,
yes.
this is the what you're going to see. But let me try to open your mind with this one also. Okay. The key here is to obviously open this guy up. I'm going to come back to this tomorrow. You guys know the quadrants, no?
Yes.
yes,
Okay.
sir.
First thing, we measure angles anti-clockwise. Is it fine with everyone? No? We're happy with this?
Yes.
Okay.
Mm.
We know that. Measure angles anti-clockwise. Anti-clock. Wonder why. Are we happy with that, no?
Is it positive angles?
No,
Eh.
that's yes, that's a positive angle. Yes, that's how we measure. That is what I'm measuring. Are you with me?
Yes.
Okay. So what I'm saying to you, this is obviously 0. That's 90. Can you see what I mean by we're going anti-clockwise? It's just fine to everyone, right? And that's 360. Are we happy with this?
Yes.
It's
Yes,
a
sir.
complete revolution. Perfect. So this quadrant over here, we can also call it 90 minus theta. Is it not so? Because any angle here, right? It's less than 90. Does it make sense?
Yes.
That's why we call it 90 minus theta. Is everyone understanding of what that means? No? 90 minus theta, right? Are we happy?
Yes.
So what we're just first doing is obviously establishing the framework of tricks. I'm gonna blow your mind right now. Don't worry. Obviously, this one also here could this also could be 90 plus. Am I right? Why not? Is that correct?
Yes, sir.
Yes,
Yes,
that's
sir.
correct. That's 90 plus that angle, a certain angle. However, what they typically do, they rather use 180 minus, and there's a reason why. Okay. Explain to you now. No, 180 minus. Is it fine to everyone?
Yes.
The
Yes.
guy at the bottom obviously must be 180 plus. Am I right? That makes sense. Am I correct?
Yes.
Yes,
And this
sir.
guy here, we make it 360 minus. Is it fine?
Yes.
Yeah. we could also look at this as 270 plus theta. Am I right?
Yes.
So I'm just giving you different ways of what it could look like. So we're happy with this. No? We all know where these things fit. Am I right?
Yes.
Okay, perfect. So let me just I'll just erase these ones. Now we have these trig ratios. We have the sine, we have the cos, we have the tan. If we call its brother or sister. Are you familiar with these ones, right?
Yes.
Right. Okay. So the purpose of this now is to identify where these trigonometry ratios are positive or negative. I'll explain to you why it's important. But anyway, so in my first quadrant, we're gonna call this quadrant 1. Is it fine? 2, 3, and 4. What are which trig functions are positive?
All are
All
positive.
of
All are
them.
positive.
Okay. The next one,
Sine and cosine.
Sign.
Sine.
sine, right?
Sin and cosec.
Cosec, that's correct. Sine and cosec. I'm just gonna, you know what I mean. This one is gonna be
Tan.
And
yes. Other one,
cos.
cos, right?
Cos.
Okay. Yeah. So obviously, yeah, all of them are. This is sine and cosec. This is tan and cot, and this is cos and sec,
Sec.
right? And with the one is positive, the others are negative. We're familiar with that, right? So if
Yes.
sine is positive
Yes.
there, then the other two is negative. Now my question to you is why? Why are they like this? Because I just told you, or do you actually know why? Who can tell me? Maybe I should say I'm gonna buy them a bottle. Maybe their brain will work a bit better. Does anyone know why?
I think the y is got a negative and a positive, and the x is got a negative and a positive. And then
Yeah.
obviously, if you measure it from that quadrant, if you go now, say for instance, the negative, let's say -4,
Hmm?
if you do the angle tangent,
Yes.
that is and it's laying the second quadrant because the x is negative and the y is positive.
That I hear what you're saying. Yes, yes, that is you close, you close. I guess the motivation worked a bit. That is also fine. But can I show you exactly where this is coming from? Do you wanna see?
Yes, please.
Be ready. Just be ready. Do you guys know how your graphs look like?
Yes, sir.
Okay.
Yeah.
Huh?
Check
Yeah.
this out. Let me open your mind. Obviously, I want us all to focus on this part of the graph here. No? The right-hand side, is it fine? Let's just the side here. Is it the right-hand side? This here. You know what I mean? That side. Ignore the other side. You know what this graph looks like, right?
Yes.
Okay. Now I'm gonna ask you a question. Look at between 0 and 90 degrees, right? For the sine graph. Are you guys with me? Between 0 and 90. Is sine positive or negative?
Positive.
Positive.
Right, no? Are we happy with that?
Yeah.
Between 0 and 90 is cos positive.
Positive.
Yes.
Yes.
That's on top, right? At 10, between 0 and 90, is it positive?
Yes.
Yes.
Okay. Interesting, eh? That holds water. Let me take it further. That what I just did now is all. No? By the way. Now let's see, is sine positive between that? Is sine positive between 0 and 180?
Yes.
180 minus. Am I right?
Yes.
That's why sine is positive there. Or 180 minus, you know what I mean? Yeah, yeah. Anything 180 less than, sorry. Is cos positive between 180? You know what I mean?
No.
There. No, right? It's negative,
No.
right? Am I right?
Yes.
Is tan negative?
Yes.
Yes.
Yes. That's why sine is positive, the others is negative. Are you with me?
Yes.
Look at tan now. Tan is positive from 180 onwards, am I right?
Yes.
So 270,
Yes.
it's positive. Let's look at cos. Cos is negative between 180 and 270, am I right?
Yes.
Likewise
Yes.
with sine, 180 and 270. That is why sine and cos is negative there. Obviously, you can apply the same logic to the other one. That's the reason why. It's the graphs. You guys see that?
Yes.
Yeah, the functions are telling you where things are positive and negative. I don't know if that opened people's minds, just by the way.
It did.
Yeah.
Oh,
It's
sorry.
not, yeah. It's not just, you know what I mean? It's just not what it is. Then I'll just quickly end this here before I tackle that problem. By the way, if you're ever familiar with what the other graphs look like, here they are. This is what the other graphs look like. That is your cosec graph, that's your sec graph, and that is your cot graph. Just by the way, if you ever wondered what they look like. They actually are functions as well. Nevertheless, here we are. That's a complete understanding of where that comes from. But let's quickly come back to this now. Where are we now? Okay, so this one is fairly easy. So the same mind, right? We're gonna apply the same principles here. Is that fine to everyone?
Yes, please.
I'll come back to the negative angle now. It's fairly easy. So is sine 180 minus positive or negative? Tell me.
Positive.
Positive. So you say sine theta. Straightforward, right? That's it. Is tan 180 plus theta positive or negative?
Positive.
Positive. So tan theta, am I right?
Yes.
Now let me take it a bit further. You ask, sir, but why are you reducing, right, this thing into just sine theta? Why? Why can you just do that? I tell you why. I use the compound rules. Do you remember your compound rules we just started with? You guys, I keep on forgetting it. Do you know what it is?
Yes, yes.
Let me do it quickly. It's like it's sine 180, am I right? And then what is it equal to again? It's 180, and then I just can't remember these things. You know your double angles, man. Your compound stuff. Let me just quickly get it for myself. Sine 180. What is it again? Sine. Where is it again? Yeah. Okay. So it's cos B, right? So this must be what? Cos theta. You know what I'm saying to you? The compound thing, no? You guys with me? The compound one. This one, man. Let me just screenshot it. Okay. Just battling with this thing here. What's it? You know what sine A cos B? You know that's the one, man. Cos B is what? Cos A is what? Plus cos A is 180, and then sine B. This one. You guys know what I'm talking about?
Oh, yes, yes.
Yes, sir.
Yeah, that's what I'm saying to you. Okay, let me just screenshot him so you can see him again. Now, if you know your stuff, obviously on the graph, what is this now? Let's do it like this. So this must work out. What is sine 180 again? You guys remember? Sine 180. Here's my graph. Did I remove the graphs now? Let me just go back. Sine 180 should be 0, I think, eh?
It's 0, so.
Yeah, am I right?
Yes.
Okay, copy. Just want to paste in so you can see. So we will have visual interpretation. As you can see, I just tried to remember the graphs for some reason. That's so sine 180 is 0. You guys agree with me there?
Yes.
You guys see it?
Yes.
Perfect. Come back here. Where am I now again? Am I here? So that's going to be 0. So that'll be sine. This will be 0. That'll be cos theta. Obviously, that's going to be 0, right? Plus, what is cos 180? I'll come back to my graph here. Cos 180 is what? Negative 1.
Negative 1.
Is it right? Are we happy with that?
Yes.
Okay, where are we now? Over here, past paper, negative 1. Negative 1, and then it must be sine. Am I doing this right? Am I missing something here? Oh, flip, I'm using the wrong one. That's a negative, man, not a positive one. Sorry. Yeah. Bear with me. But I think you guys get the logic what I'm trying to do here, no? Sorry about that, man. I got too excited. Yeah. You see there? It's a negative, no? We're subtracting two angles. So I must just adjust here. Yeah, so it's that. This must be negative over here. It's the same thing, but this must just be negative. No? Am I right?
Yes.
Yeah. So this becomes negative over here. Right? Guys with me? So 0 times cos is what? 0, right?
0.
Negative, and this is a positive. Am I right? Negative. So I say negative, and then I'm going to say this is negative sign. Are we happy with this? But that negative times that makes it a positive.
Positive.
That is why sine 180 minus positive. It's with a graph, and I proved it with this. Are we happy? You see how you
Yes,
can
sir.
easily find out, even if you lost here, you can just go back to the compound rules and just check if you're right.
Oh, okay.
I don't know who connected with that.
Yes. Now it makes
Yeah.
sense.
Yeah, so your compound laws is another way of, you know what I'm saying to you? Yeah, okay. So what is my 360 plus theta now? What is that one? Interesting.
The first quadrant, so
Exactly, it's the first quadrant. Is cos negative or positive there?
positive.
Positive. Perfect. Let's manage this logic in. The cos 90 minus theta, what is that one?
Positive.
Positive. Must just be careful that one. It's also that there is something called a co-ratio. You guys know about that, no? Yeah, it's another one you must also be on the lookout for. I must probably come back to that. So how do you deal with the negative angle? So cos negative theta, what's happening there? Who can tell? Who can talk to me about that? Does anyone know? You just say yes or no?
I think sir, it's where cos is negative.
Yes, but like so when you
There's
see a
two
negative,
quadrants that is negative.
sorry, I must that.
I say there's two quadrants, it's cosine is negative.
Okay, let me explain to you what's happening there, man. So when you see a negative angle, right? Remember we agreed on something that positive is basically I'm just trying to, I don't know why I can't. I'll just show you on a diagram here. Remember we agreed that anti-clockwise is how we measure an angle, and that's positive. Just want to quickly show you here. Where is this? So I can find it. Okay, let me just use my yeah, okay, perfect. So if you have an angle like this, right, coming from here to here, right, that's a positive angle. Am I right?
Mhm.
Okay. But if the angle you're measuring is going downwards now, right, that is called a negative angle because we will go in the opposite direction. You understand? So what I'm saying to you is basically when you have a negative theta, right, you're basically in the fourth quadrant. Are you guys happy?
Okay.
You got me? Because now remember, if you're measuring this way, you're going plus theta. I don't know if that makes sense. The anti-clockwise. But if you're going this way, it's negative, man. You know what I'm saying to you? That's a negative angle. So anything, now I'm gonna pull up the ratios, the negative angle, the negative angle. I'm trying to give you all the quick shortcuts as I go, trig angles. And you'll see exactly, instead of trying to remember them, or just knowing how the graphs are being, you know what I mean? Where can I find one? Yeah, this should be kind of good enough. I think so. Yeah. Copy. Let me just use this as an example. So we have a negative angle. Okay, we just got this from the internet. They call it the negative angle identities. So obviously, if we see sine negative theta, it's going to be negative theta. And it's quite simple. The reason why is because in the fourth quadrant, right? If you have sine negative theta, in the fourth quadrant, sine is negative. Am I right?
Yes.
Yes, sir.
If we have cos negative theta, that's in the fourth quadrant. Is cos positive or negative? It's positive.
Positive.
That's why it's cos theta. You see what I'm saying to you? You put tan negative theta. Is cos positive and is tan positive or negative in the fourth quadrant? It's negative.
Negative.
This is negative tan theta. You understand? That's all. And you apply the same logic to the rest. Is it clear to everyone? I hope it's clear.
Okay, but in the second quadrant, cosine is also negative. So how do we know it's in the fourth quadrant?
That's what I'm saying to you. This negative theta denotes you're moving this way. You're in the fourth quadrant.
Okay.
You understand what I'm saying to you? This negative theta. So if you have a negative angle like this, so you have cos negative theta, that means cos is going to be positive. Are you with me?
Sir,
Yes.
doesn't the positive or negative of the cost still stay the same even though it is in a
No,
negative?
it's still the same. What I'm saying to you is that, see sine negative theta, you see that over there, right?
Mm.
This is in the fourth quadrant because you're not anymore measuring that way. You're coming down clockwise, man. So this is going in the fourth quadrant. So all this is based essentially on the fourth quadrant. I don't know if I'm with you, dumb. If you're with me, dumb. That's what it is.
So yeah, so once you have a negative theta, you measuring clockwise, so to speak.
That is correct. That's what I'm trying to say.
Okay.
Yeah.
Okay.
Yes. And if you follow that logic of the normal, it's still the same cost. It's still the same, you know what I mean?
Yes.
What is it? Still the same thing. Yeah. Cause, yeah, anyway. Yeah.
It still applies. Your angle,
Yes.
well, how can I put it? It's still positive or negative in the quadrant that
Yes.
it's supposed to be.
Yes. That's what I'm trying to say. It's still the same. It's just that now you're coming that
It's
way.
just that your angle that you have a 360 minus theta will be in the fourth quadrant. Or is
Yes,
it 90 minus?
It's not about just know it like this. It's not about 90 minus, just that
If
you're
it's-
measuring the other way. Yeah.
Yeah, going
Yes.
clockwise.
Going clockwise. Yeah. That's it. I don't want to we'll get into that. So if you see tan 360 minus theta, that's in the what? What quadrant is this? The fourth one, right?
Fourth.
Fourth one.
And is tan positive or negative?
Negative.
Negative.
Negative. So we just do that. So over here, obviously, we can just reduce now, right? We can divide out. Am I right? That and that. Are we happy?
Yes.
10 and a 10,
Yes.
right? And we left with the sign and the cos, but a negative at the bottom. So it says negative sine over cos. And our answer is what?
Those the
Negative,
tangent.
negative 10. Yeah.
Mm.
I believe that's right.
Yes.
Yeah.
Yes, sir.
It was not positive or negative. You never know. They might have. Is it correct? Is it the best way we can simplify that? I'm trying to think of another way. There's another alternative we can do. I'm just thinking now. Yeah, I can tell you there's another way. You see this cos 90, right?
Yeah.
Yes.
I don't know if you guys know that cos 90 minus
It's
theta is equal to sine theta.
Sine theta.
sine theta.
Yeah, you see, if that is the case here, because normally when they do this 90 minus, it's always like a hint of you have to make it into sine. So I'm thinking we just put in a sine here. Why not? And we just divide both sides out and we get the answer of -1 basically. There's a negative at the bottom. So it's -1. So yeah, so I think both answers are valid, by the way. Just letting you know. I can prove it to you that both answers are actually right. So yeah, there's two ways to get that one in. But do you guys learn about how the angles work? Are we comfortable with that now?
Yeah, we can
Okay. So
just
guys, I
more
think
practice.
with the end of today's session, tomorrow I'm going to do trig identities. I might start off with one of these ones. Tomorrow is warm up. And then I'll do equations tomorrow. Yeah. And then next week you'll do functions.
Okay.
Yeah. Is there any other any remarks, comments before we move on, or questions? Or before we close?
I'm not
no.
sure if we did graphs.
Now we're doing graphs next week.
Okay.
Yeah,
But
functions.
aren't we writing on that Monday, Tuesday,
Who said you're writing Tuesday?
on the 24th?
Oh, you guys, I think your final on the 24th already.
Yes, sir.
Yes, sir.
That's what the thing says.
Oh, flip. Yeah, so we're still going to do functions next week, yeah. I'm still seeing you guys next week, you know that.
So the 24th is the week after that.
Yes.
It's a Monday.
Yeah.
No, man,
So-
isn't it a Tuesday? Don't make me know.
Nah,
It's
it's a Monday.
It is
It's Monday.
Tuesday, man.
It's on a Tuesday, guys,
It's a
please.
Tuesday.
No, it's a Monday.
It's a Monday,
Yeah.
guys.
Oh,
Yo.
yo.
So I don't
But
know.
sir, can't we
Yeah.
then maybe do a class during the week?
No, we can.
If possible, because it's gonna be too much if we're getting it on Friday evening and then we still have to.
So when can I do it? Can we do it on, maybe have a class on Monday or so? Is that fine?
Yes.
17th.
Yes,
Any-
yes.
Any
Yes, that
day
can
is
work.
okay with me.
Okay,
Yeah,
because
any week is fine.
Thursday I have my strengths, so that is why. Yeah, okay, so we can do Monday as well. So we can do tomorrow the last of trig, and then we can continue with functions on Monday. But it's not bad, man. So again,
Can't we do it on Tuesday? Because Monday I also have a class on Monday.
thing is Tuesday I have this workshop, but I'm gonna see, man. Remember, I'm still gonna record the lecture anyway.
Oh, okay.
So yeah, so if you call it in, it's fine. But I'm just trying to shift it as the best possible way. Yeah.
Okay, sir.
So are we
Um,
doing Monday?
Yes, Monday's fine. I'll put the announcement on the group.
Okay.
Okay,
Thank
guys.
you,
Thank
sir.
you. Hope you guys learned something. I'll see you tomorrow morning, 9 o'clock. And we'll try to finish up with Trigs. And Richard, again, thank you for all the questions, man, and everyone else. But yeah, I appreciate the engagement. That is what I want. I don't want to be talking the whole time. Okay, right. So I'll see you tomorrow. We're gonna do one more reduction. That's the one we just did now, and then we'll continue with the equations. Okay then. Cheers, guys.
Thank you so much.
Okay,
Thank
And
you,
please
sir.
don't. No,
Thank you, sir.
black labels
Thank
bad
you.
for the brain. Yeah, please. Cheers, guys. Cheers.
okay, bye.
Bye.
Bye-bye.